Okay, so in Algebra 1, one of the most important things that you're going to learn is to solve an equation. And what that means is to get a variable all by itself on one side of the equal sign. As you can see, m, our variable, is not all by itself because you're adding 4 to m. So I need to get rid of plus 4. The way you get rid of a plus 4 is you subtract 4 from both sides. This is called an inverse function. Subtraction is the opposite of addition. When you do that, the 4 and the minus 4 become 0 and cancel each other out. On the left side, the m drops down, the equal sign drops down, and then you do negative 12 minus 4, which is negative 16. Now that m is all by itself, also known as isolated on the left, you're good. You got your answer. You're done. And m equals negative 16. And that's my answer. In Algebra 1, you're going to solve a lot of equations. And what you do to solve an equation is you make sure you get a variable all alone on one side of the equal sign. Well, v minus 15 means v is not alone. Minus 15 is in the way. So the way you get rid of minus 15 is you do the opposite of minus 15, or the inverse of minus 15, and that's to add 15. But if you do it to one side, you have to do it to the other. So minus 15 and plus 15 literally cancel each other out. Drop down the v, drop down the equals, and negative 27 plus 15 is negative 12. Now that v is alone all by itself, we're done and we have our answer. In Algebra 1, we're going to have to solve a lot of equations. And by solving an equation, what we do is get a variable, in this case x, all by itself. Now, negative 17 is being multiplied to x, which means x is not all by itself. How do you get rid of negative 17 in this case? Do the inverse of negative 17 times and divide both sides by negative 17. When you divide negative 17 from negative 17, they become 1, which means you have 1x, which means you just drop down 1x. Drop down the equal sign, and negative divided by a negative is a positive, and 204 divided by 17 is 12. Now that x is all by itself alone on the left, you are done. Circle your answer, one-step equation, call it a day. All right, so to solve an equation, what you have to do is you have to figure out what's happening to our variable and get rid of everything else around it. A is not all by itself. I have to isolate A. I have to get A all by itself. A is being divided by 18, so I have to get rid of getting divided by 18. How do you get rid of divided by 18? Well, you do the inverse of divided by 18, and that's multiply both sides by 18. So we're going to wrap both sides in parentheses, like so. 18 up here and 18 down here cross each other out. Now that leaves me with just a positive A on the right. 18 times negative 5 is a positive times a negative, which is a negative, and 18 times 5 is 90, so 18 times negative 5 is negative 90. Now, this is a correct answer, and most teachers would be okay with this, but some teachers might want you to say, well, that doesn't sound proper. Negative 90 equals A is like saying Math Teacher Goat is my name. We want to say my name is Math Teacher Goat. Unless your name's not Math Teacher Goat, then please don't say that because copyright infringement. So what we're going to do is we're going to flip these around. If negative 90 is A, then A is negative 90. So I personally prefer the guy right here in the circle, but the guy right here in the box certainly isn't wrong. Either one should work just fine on a test or a quiz or homework or whatever. Ladies and gentlemen, this is a two-step equation. With two-step equations, what we have to do is we have to figure out what's happening to our variable so that our variable is not alone. Well, first off, we're dividing by 4, and then we're adding 2. What you want to do is always get rid of the thing that you're adding or subtracting first, then deal with the thing that you're multiplying or dividing by. We are adding 2 in this case, so we want to first get rid of 2. The way we get rid of a positive 2 over here is do the inverse of positive 2, which is minus 2, and we're going to do that to both sides. So minus 2 minus 2. 2 minus 2 becomes 0, which means you are now useless. On the left, we have 6 minus 2, which becomes 4, equals nothing happened to A over 4, so that stays the same. Now, a is not by itself yet because divided by 4 is in the way. How do you get rid of divided by 4? Do the inverse of divided by 4, and that's multiply 4 to both sides. So I wrap both sides in parentheses, like so. I multiply both sides by 4, like so, and 4 over 4 crosses out. On the right side, you have just an A, and on the left side, you have 16. Now, most teachers should be okay with this. 16 equals A is an acceptable answer. But for whatever reason, as a teacher, I prefer my variable on the left. It's kind of like saying Nick is my name, but you should say my name is Nick. So instead of saying 16 equals A, say A equals 16. Either one's good, but blue is just a little bit better, isn't it? It is. Two-step equations. We have ourselves a two-step equation to solve, and whenever you solve, you're trying to isolate the variable. We got to get this variable all by itself. Now, we have to take a look at what we're doing. We're subtracting 7, and we're multiplying 9 to our variable. What you always want to get rid of first is the thing that you're either adding or subtracting. Get rid of the adding or subtracting thing first, and then deal with anything that you're multiplying or dividing. So that's supposed to be a division symbol, and it looked weird. Too late. So I have to get rid of the thing that we're subtracting first, and what we're subtracting is 7. So how do we get rid of minus 7? Well, you do the inverse, which is plus 7, and you have to do that to both sides. So you add 7 to both sides. Now, this is weird. It's not wrong, it's weird. If minus 7 plus 7 crosses out and becomes 0, then minus 7 plus 7 also crosses out and becomes 0. So the right side becomes 0. I don't need to write out the 0 here. All I have to do is just drop down the 9x. Now, if you're thinking, we got a 0, we did something wrong. No, we did not. See, we still have to get rid of 9. Since 9 is being multiplied to x, we have to do the inverse of multiplying 9, and that's dividing both sides by 9. 0 divided by 9 is 0, so x equals 0, and that's a legitimate answer. And that's the answer that we get here. So not a crazy problem, not an easy problem, but definitely doable. We have ourselves a two-step equation in which we are dividing an entire side by a number. Whenever you have an equation where you divide an entire side by a number, the first step you're going to want to do is multiply both sides by that number. So I'm going to multiply both sides by 6. What you're allowed to do then is just cross out the 6's on the side where 6 is on the bottom in the denominator. The left side is going to be 6 times negative 1, which is negative 6. On the right side, since the 6's cancel each other out, I really don't need that fraction bar. So drop down just to 5 plus x, and now it becomes a one-step equation. X is not all by itself. 5 is floating around. It's a positive 5, so in order to get rid of a positive 5, you subtract 5 from both sides because subtract is the inverse of positive. Negative 6 minus 5 is negative 11. Drop down the equals, drop down the x. Now, this is a legitimate answer. You're allowed to circle this and say, I'm done. But as a teacher, I really like to see my variable on the left side. So this is a quick fix. If negative 11 is the same as x, then x is the same as negative 11. It's all good. Either one of these are perfectly fine, but I prefer to put my x on the left side, and that's what I just did. So, stop me. Go through the internet and stop me. Thanks for watching. Let's solve an equation involving the distributive property. Now, the distributive property is when you have a number multiplied to a set of parentheses when you're doing more than one thing inside the parentheses. What you're going to want to do with distributive property is take that number living outside the parentheses and multiply it to both or however many items live inside the parentheses. So negative 12 times x is just negative 12x. Don't overthink it. Negative 12 times positive 5 is negative 60. 114 drops down on the left like so. Now what we have is a regular two-step equation. X is not alone on the right side. You have a minus 60 and a negative 12 being multiplied to it. Minus 60 is just being subtracted. So whenever you have a two-step equation, when you're multiplying, dividing, and adding, subtracting, you're going to always want to get rid of the thing that you're adding, subtracting first. Since we're subtracting 60, we want to do the inverse of subtracting 60, which is adding 60 to both sides, like so. This crosses out. 144 plus 60 is 204 last time I checked. Drop down the equals negative 12x, and now we have just one step to go. Now, x is still not alone all by itself on the right side. Negative 12 is being multiplied to it. The way you get rid of that negative 12 if it's being multiplied is you do the inverse of multiplication, which is division. So divide both sides by negative 12. Divide both sides by negative 12. And 204 divided by negative 12 is negative 17. Okay, positive divided by a negative is a negative. 204 divided by 12 is 17. Trust me on that. And you get equals x. Now, this is a correct answer, and most teachers would be okay with that. Now, as a math teacher, I don't like my variable on the right. It just doesn't seem prudent. I like to put it on the left. Is it wrong if I keep it like that in the red box? Nope. Does it look better if I keep it like this in the purple circle? You better believe it, baby. Ooh, look at this. We have ourselves an equation with two variables on the same side of the equal sign, and they're the same variable. Boys and girls, this is called combining like terms. And if you see two variables on the same side of the equal sign, or two numbers or any like terms on the same side of the equal sign, combine them, don't think a second thought of it. Negative 4x take away negative 6x combines. Negative 4 minus 6 is negative 10. So negative 4x's minus 6x's is negative 10x's. So the right side simply becomes that because you combine like terms. The left side is still negative 20. Now what we have is a one-step equation where negative 10 is being multiplied to x. See, x is not all alone. Not yet. Negative 10 is being multiplied to x. How do I get rid of multiplying negative 10? Do the inverse, which is divide negative 10. From both sides. So let's cross you out. Negative 20 divided by negative 10 is a negative divided by a negative, so it becomes a positive, and 20 divided by 10 is 2. So 2 equals x. Now you can box that in, and most teachers would be like, that's perfect, you're done. But some teachers would rather you put the x on the left side and the 2 on the right side. If 2 is x, then x is 2. It's all the same thing, but the purple circle is just a whole lot better than the black box. Oh boy, we have our first equation with variables on each side of the equal sign. This is what I like to do. If you have a variable on the left side of the equal sign and a variable on the right side of the equal sign, you're allowed to pick any variable you want to get rid of. But I always want to get rid of the variable on the right side first. That's just what I like to do. So what I'm going to do is I'm going to notice that I have minus 5a on the right side. How do I get rid of a negative 5a? Well, the opposite of negative is positive, so let's add 5a. Now, if I'm going to add 5a to the right, I have to add 5a to the left, and I'm going to write it underneath that a because those are like terms. Okay, the negative 5a and the positive 5a on the right cancel each other out. 1 apple plus 5 apples is 6 apples. How about them? Drop down the plus 5, drop down the equals, and drop down the 5. Now I have myself a two-step equation. Whenever you're multiplying by a variable and adding, you always get rid of the adding guy first. So I'm going to subtract 5 from both sides because subtraction is the inverse of addition. That crosses out. Now this is weird because if a positive 5 minus 5 crosses out, then a positive 5 minus a 5 should cross out, which means on the right side I'm left with nothing. On the left side, 6a drops down. Now before you freak out and say, we did something wrong. No, you didn't. Divide both sides by 6 because 6 is being multiplied to a, so you divide both sides by 6. Right, that crosses out. The a drops down, and 0 divided by 6 is 0. 0 is an answer. You're allowed to get it, and we just did. Okay, so that's our guy. A is 0. Bada bing. Oh my goodness, look at all those peas. It's like I'm eating a shepherd's pie because of all the... On the right side, we have 5p and 3p. On the left side, we have a regular p. So this is what you're going to want to do. what you're going to want to do is if you see like terms on any side of the equal sign, combine them. If you look at the left, I have a p and a -1. They don't combine. But if you look on the right, I have a 5p and a 3p on the same side. 5p's plus 3p's is 8p's. Okay, drop down the p -1 equals 8p is there, drop down the -8. Now we have variables on the left and the right side of the equal sign. What I like to do is I like to get rid of the variable on the right side of the equal sign because that's just me. You could get rid of the p, but I always like to get rid of the variable first, and I always like to get rid of the one on the right side. So I have a positive 8p. I'm going to get rid of a positive 8p by doing its inverse, which is minus 8p from both sides. Now, this is invisible 1, so if you need to put a 1 there, go ahead. 1 minus 8 is -7. So 1p minus 8p is -7p. Drop down the -1, drop down the equals, and drop down the -8. Now I have a two-step equation. P is not all by itself. -7 is being multiplied and -1 is off to the side. Always get rid of your number that you're adding or subtracting first by doing its inverse. So that means add 1 to both sides, cross you out. -8 plus 1 is -7. Drop down the -7p on the left. Now I still have one more step to go. -7 is being multiplied to p. In order to get rid of being multiplied to p, you have to divide both sides by whatever that number is, and so you divide both sides by -7. That crosses out, and a number divided by itself, so -7 divided by -7 is 1, and I'm going to write it over here. So p is going to equal 1. So after all that, p is 1. Okay? So that's it. We're done. Crazy, but fun. Made a rhyme. All right, so as problems get more complicated, you really need to look at what you have in front of you before you start doing it. We have an n on the left side of the equal sign and an n on the right side of the equal sign, which means I'm going to have to get rid of one of them at some point. But even before that, we have distributive property. So if you see distributive property in any solving equations problem, that's probably what you're going to want to do first. So we have -8 times 6, which is -48. We have -8 times +5 and -8 +5 multiply out to -40, and n comes along for the ride. Nothing happens with the left side because we did nothing with the left side. So drop down the 3n, the -5, and that equal sign right there. Now you have an equation with n on both sides of the equal sign. You're allowed to get rid of any one of these n's, but I like to get rid of the right side first just because that's the way I am. So I have a -40n on the right side. Let's add 40n because that's the inverse operation of -40n. So add 40n, write that underneath the 3n over here because those guys combine. The right side cancels out because a -40n and a +40n just kill each other off. Now on the left side, I have 3n plus 40n. So that's like saying 3 ninjas plus 40 ninjas is 43 ninjas. Sounds like a great movie. Drop down the -5, drop down the equal sign, drop down the -48, and now you have yourselves a regular old two-stepper. Is n all by itself? No. Times 43 is in the way, -5 is in the way. Always get rid of the thing that's being added or subtracted first, and do that by doing the inverse. So the inverse of -5 is +5, so we are going to add 5 to both sides. The -5 and the +5 cancel out. 43n drops down. That's gone. Equals drops down, and -48 plus 5 is -43. Now, in order to get n all by itself in this last step, we notice that 43 is being multiplied to n, so the inverse of multiplied to n is divide by 43, and you're going to divide 43 from both sides. That crosses out. A negative number divided by itself is -1, so -43 divided by regular 43 is -1. Okay, so again, distributive property first, get rid of the n on the right, two-stepper, fun, fun, fun. All right, so take a look at this problem, and it's pretty much a mess. We have distributive property over here. We have distributive property right next to it, and then it just equals a 43. So whenever you have a problem that involves distributive property, that's what you're going to want to do first 99% of the time. Now we have two separate distributive property problems. Treat them separately. So I have -3 attached to 4x plus 3. Multiply to -3 to 4x, that gives you -12x. Multiply the -3 to +3, and that gets you -9. That parentheses is donezo. This distributive property problem is completely separate from that. 4 times 6x is positive 24x. 4 times 1 is 4. And then nothing happened on the right side, so let's just drop down the right side. Now, on the left, if you can combine like terms, do it. In fact, not only do we combine once, we combine twice. -12x and 24x both have x's, so they're like terms. So if you view this as 24x's minus 12x's gives me 12x's, you're in great shape. Sounds like my dating history. 12x's. Now I have -9 and +4. Those are like terms because they're just regular old numbers. And -9 plus 4 is -5. What happened to the equals 43? Nothing. 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 So now we have a regular old two-stepper. X is not all by itself. We have 12 being multiplied, and we have -5 floating around. Always get rid of the number that's being added or subtracted from your variable first, and we do that by taking the inverse of -5, which is adding 5 to both sides. Drop down to 12x because nothing changed there. These guys canceled out. Drop down the equals, and 43 plus 5 is 48. 12 is being multiplied to x. How do we get rid of multiply 12? The inverse is divide 12. So we're going to divide 12 from both sides. That crosses out. Now x is finally isolated, and 48 divided by 12 is 4, and that's going to be our guy. So the key again with this problem is if you can distributive property first, distributive property first. In this case, combine like terms on the left side. It turns into a two-step. Not great, but not bad either. This problem is an absolute train wreck. This is what I'm looking at. Distributive property number 1, distributive property number 2. Those are separate. X is on the left, X is on the right. Those are separate. So when I see problems that look like they involve distributive property, look like they involve combining like terms, and look like they involve doing stuff from both sides, I always go in this order. Step number 1, distributive property. Step number 2, combine like terms on each side. And then step number 3 is get rid of whatever variable that you're dealing with. So I'll say get rid of vary. Then we'll take it from there. So step number 1 is going to be distributive property. I have two sets of distributive properties on the left. -5 only deals with this parentheses here, so only use -5 for that parentheses. -5 times 1 is -5. -5 times -5x is -5 times -5 is positive. 5 times 5 is 25. X comes along for the ride. You're done. Now, regular 5, because that's a positive, is going to be multiplied to -8x. So 5 times -8x is -40x. Regular 5 times -2 is -10. And now we're done with that distributive property problem. On the right side, if you want to combine like terms, you can, but I won't yet. So -4x and -8x on the right side combine. Now is the time, so done. Now is the time where I want to combine like terms. All right, so on the left side, I see a -5 and a -10. Those are both regular numbers. -5 and -10 add up to -15. They're both negatives, and when you subtract a negative from a negative, you still get a larger negative. And that's what we have here. We now have positive 25x minus 40x. 25x's minus 40x's is minus 15x. So that's me combining like terms on the left. Should I put a check mark here? No. because I can combine like terms on the right side. On the right side, what color didn't I use? Let's go with blue. I have a negative 4x and a minus 8x. Those guys combine like right away, negative 12x. Now, if you're thinking, all right, now I have a two-stepper, you're thinking wrong. I still have an x on the left and an x on the right. Now, usually what I like to do is I like to get rid of the variable on the right. However, if I get rid of the variable on the right by adding 12x, even though it's not wrong, it gives me an extra step to do, and I'm lazy bones. So this is what I'm going to do. I noticed that if I want to try to get 15, negative 15 alone over here and maybe get rid of u, I could just add 15x to both sides. And that's what I'm going to do. That allows you to cross out. And now instead of having two things on the left side, I have one thing on the left and one thing on the right. The negative 15 drops down. You're gone. Equals drops down. 15x's minus 12x's is 3x's. Now, in order to get x all by itself, 3 is being multiplied to x, divide both sides by 3, inverse, divide both sides by 3, and negative 5 is equal to x. Most teachers would be okay with this, but I'm the type of teacher where I just prefer, although I would never mark this wrong, I prefer that instead of saying negative 5 is x, you say x is negative 5. It just sounds prettier and it's more helpful to when you get to this thing called inequalities, but that's all right. You're not there yet. Right now, either one of these will work. But this was a train wreck of a problem. Very difficult. But again, if you can do distributive property, do that first. If you can combine like terms on each side, do that second, and then take the rest of the problem the way you normally would. Fun. This is an absolute value equation. And the way you solve absolute value equations is once you have just an absolute value wrapped around a variable like we have here, even though there's 6 attached, don't worry, you go over to this little rule over here that says if you have the absolute value of stuff, and I'm going to make it a smiley face, okay, and that equals something, what you do is you split it up into two equations. You write out whatever's in the left or in the absolute value, so smiley face, whatever that may be, you set it equal, and then you have two equations where one of the equation you write out the original right side, and the other equation you write out the opposite of the right side. This is what I have. I have the absolute value of stuff equals 42. So what I need to do is split this up into two equations. You write out whatever's inside the absolute value, 6m and 6m. You drop down your equal sign. Then one of your equations is going to have the original right side, and the other equation is going to have the opposite of the right side. The opposite of 42 is negative 42. So now what I have are two equations to solve for, and I solve for each of them individually. Is m all by itself? No. 6 is being multiplied, so we do the inverse of multiply 6, and we divide 6 from both sides. The 6 crosses out, and m equals 42 divided by 6 is positive 7. We do the same exact thing over here. Is m alone? No. 6 is being multiplied to m. So divide both sides by 6, divide both sides by 6, cross u out, and m in this case equals negative 7. So what you should do with these types of problems is do a mental check. All right, so I'll do the mental check over here. We have two possible answers. M could be 7 and m could be negative 7. So you think in your head, all right, 6 times 7, that's the same as 6 times 40, the absolute value of 42. And the absolute value of 42 is 42, and we're supposed to get 42. So check you work, check you work. And then we do it again with the other guy. So you're thinking, all right, so these absolute value of 6 times negative 7, absolute value, gets me the absolute value of negative 42, but the absolute value of a negative just makes it positive, so we get 42 anyway. We want to get 42, Chekaruski, so you work, and then our final answer is for us to say, since it worked for both, m is going to equal both 7, also negative 7. So we have two answers, because two answers work. Okay? Fun. This is an absolute value equation. Now, if you're not too good at absolute value equations, the basic versions, go back and watch my previous video about regular absolute value equations. This is a little bit more complicated. What I need to do is I need to get the absolute value all by itself on the left so that it looks like this all by itself on the left. It's not. It's being divided by 8. So I have to get rid of divided by 8. How do I get rid of divided by 8? The inverse of divided by 8 is multiply 8. So let's wrap both sides in parentheses and multiply both sides to 8. 8 over 8 allows you to cross out. And now we have the absolute value of a minus 5 all alone on the left, which is just what I want. That's going to equal 5 times 8, which is 40. Now, this is how absolute values work. What you do is once you have the absolute value all by itself, you split it up into two equations. In both equations, you write out whatever's inside the absolute value on the left side. A minus 5, A minus 5. That doesn't change. That's an equal sign, so drop them down. That doesn't change. In one of your equations, you keep the right side exactly the way it is, so 40 is going to remain 40. Okay, the other equation, you're going to take the opposite of the right side, so positive 40 becomes negative 40. Now I have two separate equations that I solve for individually. I go over here and I say A is not isolated, I have minus 5, let's do the inverse and add 5 to both sides. So A is going to equal 45. You go over here and you say the same thing. A is not all by itself. We have minus 5, so let's add 5 to both sides. And in this case, A is going to equal negative 35. Now, what you would probably want to do in this case is go up here and do a mental check and do like 45 minus 5 is 40. The absolute value of 40 is 40. Divided by 8 is 5. Hooray! And negative 35 minus 5 is negative 40. And the absolute value of negative 40 is positive 40. Positive 40 divided by 5 or 8 is 5. Chekaruski, they both work. So your final answer is going to be you stating the fact that you have two answers. A is going to equal 45. A is going to equal negative 35. Put them both together. That is our answer. Dunzo, funzo. We have ourselves an absolute value equation. In order to solve the absolute value equations, we have to get the absolute value part all by itself. So I need to make the left side look like this. Well, that's just a one-stepper because only minus 8 is in the way. So let's get rid of minus 8 by adding 8 to both sides, the inverse operation. That crosses you out, and now I have exactly what I want on the left side. On the right side, I have negative 7 plus 8 equals 1. I can handle that. Once you get the absolute value all by itself, what you do is you split this up into two equations. Each equation, what you're going to do is keep the left side, or rather the stuff inside the absolute value, all by itself. You just isolate it. So get rid of the absolute value, make that both of your left sides. Equal signs drop down still as usual. It equals 1. So what you're going to do is for one of your equations, you're going to keep the right side exactly the same. For the other equation, you take the opposite of the right side, which is going to be negative 1. Now you take each equation, you have two of them, and you solve each one individually. I have to get x all by itself. X is being divided by 7. How do you get rid of divided by 7? Multiply both sides by 7, like so. X equals, let me see, 1 times 7 is 7. Do the same thing here. Hopefully I can say this without having to make a fart noise. X is being divided by 7. How do I get rid of divided by 7? Multiply both sides by 7, like so. That crosses out. And x equals negative 1 times 7 is negative 7. Okay, what you're going to want to do is do a mental check and make sure everything works out. You know, like plug in 7. The 7 over 7 is the absolute value of 1, and the absolute value of 1 is 1, and 1 minus 8 is negative 7. And you would do the same thing over here and get the same thing, and everything's good. And once you check your work and find out that everything is good, you realize that you have two answers. X is going to equal 7. X is going to also equal -7. And those are both my guys. So yeah, you're going to have two answers for this one as long as you plug stuff in and everything seems to work out. This is what's called a radical equation. Now, it's called a radical equation because not only is it super awesome and invented in the early 90s, but this is called a radicand. It's a square root symbol. Now, a square root symbol is being wrapped around an entire left side. If I want to get rid of a square root, the way you undo a square root is you square it. So if I were to square both sides, that will make the square root on the left side disappear like so. Now we have 3 to the second power on the right. 3 times 3 is 9, bada bing. Okay, it's a regular old one-step equation now. Add 4, v equals 13. Now with these guys, you really want to check your work because if you end up with a negative answer, that can be scary. But if I go up here and I say, all right, well, if this is me checking my work mentally, if I were to plug in 13, I would get 13 minus 4 underneath the square root. 13 minus 4 is 9, and the square root of 9 is 3. You're good. Everything's fine. 13 works. But that is how you undo a square root. You square it. Makes sense to me. This is what's called a square root equation. In order to solve a square root equation, you have to get rid of everything surrounding the square root and only have square root of 5a minus 5 alone on the left. By the way, this is also called a radical equation because in the early 90s, the Ninja Turtles loved these things. What you're going to want to do first, if we're going to get rid of -8, is do the inverse of -8 and add 8 to both sides like so. That leaves me with the whole square root of 5a minus 5 on the left, and -3 plus 8 is 5 on the right. So I got to where I wanted. I wanted it to look like that. Now it looks like that. How do we get rid of a square root? Well, the opposite, or rather the inverse of a square root, is a square. So what we do in order to get rid of the square root is we square it. And if I square the left, I also have to square the right. So the square and the square root cancel each other out. And 5a minus 5 drops down on the left. 5 squared, 5 times itself is 25. And now we have a regular two-step equation. Okay, in order to get a all by itself, I'm going to do the inverse of -5 and add 5 to both sides like so. 5a equals 30. Divide both sides by 5. Divide both sides by 5 because you are multiplying 5 to a, and a equals 6. And if you wanted to, you should probably go up here and check your work and make sure you don't get any crazy negatives. You're not allowed to have negatives in square roots, but we did it right. Nothing to worry about. Everybody's happy, and we can move on with our lives because the answer is 6. Oof! This is what's called a radical equation. When you have a radical equation, you usually have one set of square roots equals to something, like a number. But we have a square root equals a square root. So I have to get rid of 2 square roots. Well, I know that the way that you kill off a square root is by squaring it. They kill each other off. Well, if I have just the square root of stuff on the left, I'm going to square it to kill off that square root. And you know what? I'm going to do the same thing over here because that'll kill off that square root. Now what we have is 2n minus 88 equals n over 6. This is a very unique problem because I'm going to do this problem. I haven't done a video like this problem yet, at least not for my Algebra 1 videos, but we're going to learn it here because this is brand new. I have n over 6, and a lot of you might be thinking, well, what do I do with that? Why don't we just get rid of divided by 6 by multiplying 6 to both sides? Now, what that looks like on the left, if we multiply 6 to both sides and wrap everything in parentheses, is distributive property. So again, in my videos, we haven't run into this yet, but it's no big deal. We've done distributive property plenty of times. 6 times 2n is 12n. 6 times -88 is -528. I did that in my head and not off to the side after pausing the video. Now, the 6's cancel out, and you're just left with n. I have an n on the left and an n on the right. Usually what I do is I try to get rid of the variable on the right, but not this time, because if I get rid of u, I'll have two things on the left. And what I really want to do is get one thing on the left and one thing on the right. So I'm going to subtract 12n from both sides. Drop down the negative 528 equals negative 11n. Divide both sides by negative 11. Divide both sides by negative 11. And right off the top of my head, I know that this equals 48 because I didn't go off to the side and find out what it was. Now, what you're going to want to do is probably plug this in and make sure you don't have any negatives, but just looking at this, I know we won't, so I know we'll be good. But n equals 48. Some of you might have said 48 equals n. That's perfectly fine. I like to have my variable on the left. It's really not the end of the world. But that's how you do an equation where you have a square root covering the whole left and a square root covering the whole right. Just basically get rid of the square roots. They're useless. And do the rest of the problem the way you normally would. Except this problem was bananas. B-A-N-A-N-A-N-A-N-A-S. Thanks for watching. Hope this helps. This, ladies and gentlemen, is called a proportion. A proportion is when you have a fraction equals a fraction. When you have a fraction equals a fraction, it's called crisscross applesauce. You cross multiply the diagonals. So 10 times 10 is 100. You drop down the equal sign. You cross multiply the other diagonals. So 8 times n is 8n. And now you have yourself a one-step equation. Divide both sides by 8. Divide both sides by 8. And I believe 100 divided by 8 is 12.5. So 12.5 is going to equal n. And yes, you're allowed to circle that, but if you watch my videos, you know very well that I prefer my n on the left. So if 12.5 is n, then n is 12.5. Either one of these will do. I just like my n on the left. Don't judge me. This is called a proportion. And when you have a proportion, it means you have a fraction equals a fraction. So what you do is you cross multiply diagonals. Now in this problem, unlike the last problem that if you watch all my videos we have a couple things going on in this denominator here. So what you're going to want to write out is write out that 8 as normal, but then wrap that m minus 8 in parentheses, and you're going to be thinking distributive property thoughts. So again, you cross multiply one set of diagonals, you drop down the equal sign, and then you cross multiply the other set of diagonals. So I can handle 4 times 2, it's 8. Now on the left side, we have distributive property. 8 times m is 8m. 8 times negative 8 is negative 64, and you drop down the equals 8. Now we have a regular two-stepper. M is not all by itself because 8 is being multiplied to it, and negative 64 is being added to it. So how do we get rid of a negative 64? Do the inverse, which is plus 64 to both sides. Drop down the 8m, and 8 plus 64 is 72. Is m all by itself? No. 8 is in the way, and since 8 is being multiplied to m, you divide 8, and m is going to equal 9. And there you go. That's how you do proportions. Cross multiply, crisscross applesauce, whatever you want to call it. Easy peasy, lemon squeezy. This is called a proportion. A proportion looks like a fraction equals a fraction. And the way you solve a proportion is you do crisscross applesauce. What does that mean? You take two diagonals and multiply them together. Now these two diagonals, you do have a regular 8, so you're going to multiply 8 to r minus 9. You just have to make sure that if you have more than one thing going on here, you wrap that thing in parentheses. So 8 times parentheses r minus 9. Drop down the equal sign, and then you multiply the other diagonals. And it's the same exact case. 5 is 5, but you multiply r plus 5. So 5 times r plus 5 looks like this again. And what you have on the left side and on the right side is distributive property thoughts. So whenever you have distributive property, do it. 8 times r is 8r. 5r. 8 times negative 9 is negative 72. Drop down the equals. 5 times r is 5r. 5 times 5 is 25. Now you have a variable on each side of the equal sign. I prefer to get rid of the variable on the right side first. So I'm going to subtract 5r from both sides. 8r minus 5r is 3r. Drop down the minus 72, drop down the equals, drop down the 25, and now we have ourselves a two-step equation. Okay, 3 times r, we'll deal with that in a minute. Minus 72, let's take the inverse operation of that. Add 72 to both sides. So what I'm going to do is, since I'm running out of space, I'm going to rewrite this up here. Drop down the 3r, so there you is. That's gone. Drop down the equals, so there you is. And 25 plus 72 is 97. Divide both sides by 3. And you can't simplify that. That's just a big fraction. So the answer is going to be 97 divided by 3. Don't lose sleep over it. You're allowed to get fractions for answers. I'm looking at what I did, and I don't think I did anything wrong or stupid, which is a rarity. But yeah, I did it right, and we ended up with a fraction. So yeah, fun stuff. You're welcome. What percent of 29 is 3? Whenever I see a sentence like this and it deals with percents, I always try to label what I don't know with a variable. So I'm going to call percent P. So what percent means I don't know P? So what percent of 29 means P times 29 means equals 3. Now, if you want to, if it makes you feel more comfortable, you could say, all right, well, P times 29 is 29P, so I'm just going to rewrite it like that. And what we have ourselves is a one-step equation. Solve that one-step equation by dividing both sides by 29. Now, what's going to happen here is you're going to get yourself a pretty gross decimal, so let me write out a bunch of decimal points for it. So according to Siri on the old phone, I get 0.1034. Okay. Now, this is not my answer. This is just P. I have to turn this into a percent. The way you turn a decimal into a percent is you multiply it by 100. Now, what that means is you take your decimal place and you move it to the right 2 times to create a new decimal place. Rewrite that number as 10.34 and attach your percent, and that's going to be my guy. So 10%, well, 10.34% of 29 is 3. So these problems aren't the easiest because you're usually going to deal with crazy, ugly looking decimals, but that's how we do that problem. 112 minutes is 76% of what? Of what means I'm going to have a variable, so I'm going to call you x because I don't know what u is. Now, what is an equal sign. 112 minutes, what's minutes? Who cares? 112 is 76% of x. Now, it all depends on the teacher that you have, but what I have is a one-step equation, and what I have to do is divide both sides by 76%. So I'm going to split this up into 2 problems that'll end up doing the same thing. It all depends on what type of calculator you have, because you're definitely going to need a calculator for this. But equation number 1 is going to be like, teacher's going to be like, all right, kids, plug 112 divided by 76% into your calculator, and you literally type it out just like that. Now, what you'll get when you have that is 147.3684, or at least that's what my phone is telling me. We'll round it to the nearest 1 decimal place. So since we have 0.36, we'll round it to 4. And my answer is going to be 147.4. So if you have a percent button in your calculator, you're literally going to type out just that guy right here, and then you're done. But what if you don't have a percent button in your calculator? What if you're being asked to do 112 divided by 76% and you can't? Well, then you need to turn 76% into a decimal. The way you take 76% into a decimal is you put the decimal where it's usually supposed to be and move it to the left 2 times and create a brand new decimal. So we're going to do 112 divided by 0.76. You type that guy in your calculator, you get the same exact number, you round it the same exact way, and in either case, you're going to get the same exact number. Okay, it's just what we did on the left side is, hey, what if we have a percent button on the calculator? Then use it. What if we don't have a percent button? Then take that double digit number and move your decimal to the left twice. Do the same type of math. You're going to get the same thing. Crazy, but not super bad. Like that movie. Super bad. All right, kids, let's complicate things. This is a distance equals rate times time problem. Let's quick write that out. Distance is equal to your rate times time. We have a cattle train that left Miami and traveled towards New York. 14 hours later, a diesel train left traveling at 45 miles an hour in an effort to catch up to the cattle train. After traveling for 4 hours, the diesel train finally caught up. What was the cattle train's average speed? So this is what we're looking at, okay? We're looking at two different things, but what we also have is the fact that they're both the same distance. I don't care about Miami and New York. That doesn't matter. What happens is you have the diesel, no, the cattle train. So we'll put C, and it travels, okay? Now, we also have the diesel train. Boom, boom. Now they both have the same distance. So what I need to do is figure out the rate for each and the time for each. A cattle train left Miami and traveled towards New York. 14 hours later, a diesel train left traveling 45 miles an hour in an effort to catch up. After traveling for 4 hours, the diesel train finally caught up. So this is what we know. We know that the diesel train, its R is 45, so I'm going to replace R with 45. Its T is 4 for 4 hours. The cattle train, we don't know, and that's what we need to try to find. So we'll call you R, but what we do know is that it took 14 hours of traveling. Now, this distance is equal to this distance. So what we're going to do is set up an equation of R times 14 is going to equal 45 times 4. Now, R times 14 can be written as 14R, and 45 times 4 is 180. Divide both sides by 14, because 14 is being multiplied to R, we got to do the inverse, which is divide. And it's not pleasant. We are going to get 12.857. So we'll leave it at that. 12.857 kilometers per hour. We'll write that over here. All right. So the distances are the same. And we just did rate times time, set them equal to each other. Fun. All right, these are tricky. This is called a mixture problem. You have 2%. All right, these are tricky. This is called a mixture problem. You have 2% alcohol solution mixed with 66% alcohol solution. Find the concentration of the new mixture. So this is what we're going to do. We're going to make ourselves a little table. Okay, we have ourselves an object on the left. Okay, the one object is the 2% alcohol solution. The other is a 66% alcohol solution. And then we want to get a new mixture. Okay, so we're going to take, okay, and I know some of this might be a little bit redundant. We're going to take our objects. We have our percent, and the way we're going to write our percent is as a decimal okay? We're going to write out our amount, and from that, we're going to be able to get an equation. Ignore the fact that I don't know how to draw straight lines. Okay, so I'm going to take the fact that this is a 2% alcohol solution and turn that into a decimal, which is going to be 0.02. And if you're like, whoa, 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 how did you do that? Just divide it by 100. Okay, 66% is going to be 0.66, right? The new percent, I have no idea. So we'll call you, I don't know, X. We have 5 fluid ounces of the 2%. We have 11 fluid ounces of the 66%, and that gives us a total amount of 16 fluid ounces of the new stuff. Where did I get 16 from? Well, if I add 5 ounces of one thing to 11 ounces of another thing, I have 16 ounces. Just simple math. Now, the equation that I get from here is going to be found by multiplying these two numbers together. So 0.202 times 5 is going to be 0.1. Use a calculator. 0.66 times 11 is 7.26. Use a calculator. Now, the new that I get is going to be x times 16, which is 16x. What I need to do is I need to add these two numbers up that I found and set them equal to 16x. So I'll do that over here. 0.1 plus 7.26 equals 16x. 0.1 plus 7.26 is 7.36 equals 16x. In order to get x all by itself, I'm going to divide both sides by 16. I'm going to divide both sides by 16. And 7.36 divided by 16 is 0.46. Now, that represents a decimal form of a concentration, a percent. How do I turn a decimal back into a percent? Multiply by 100 or move the decimal right 2 times. So this now becomes 46.0%, or just 46%. So these are tricky, not fun at all, but the trick is to always make yourselves a table using an object. You're multiplying two things together to create a new equation, add the two equations to get a total. Happy times. Thanks for watching. Working together, Paul and Daniel can pick 40 bushels of apples in 4.95 hours. Had he done it all alone, it would have taken Daniel 9 hours. Find how long it would take Paul to do it alone. So what you're going to do is you have Paul, you have Daniel, back at it again with the white vans, and you have together. Now, you set up an equation with fractions, okay? Paul, we don't know. So let's do Daniel first. Daniel is 9 hours. So what we're going to do is we're going to do 1 over 9 for Daniel. That's the equation that you're going to do. Paul, we don't know, so we'll put 1 over x for Paul. But what we do know is together it's 4.95 hours, so we'll do 1 over 4.95. Now you're going to add the two guys individually and set it equal to what they do together. So what I need to do is I need to combine these fractions. Remember, when you combine fractions, you need denominators to be the same. So since you're x in the denominator and you're 9 in the denominator, I'm going to multiply you by 9 over 9 and you by x over x. That's going to give me 9 times 1, which is 9, 9 times x, which is 9x, plus 1 times x, which is x, 9 times x, which is 9x, and that equals 1 over 4.95. Okay, now that the denominators are the same, and I'll move this stuff up here, now that the denominators are the same, you're going to have the same denominator on the bottom, and you're going to add 9 plus x, which doesn't change. On the right side, we have equals 1 over 4.95. Now what we have is a proportion. A proportion is a fraction equals a fraction. You cross multiply two diagonals, so 9x equals 1 is just 9x. You cross multiply these guys, and since you have 9 plus x in one of the fractions, it's going to be distributed property, so I'll write it out like 4.95 times 9 plus x. Distributed property on the right. So that doesn't change the left side, but the right side becomes 44.55 after I multiply 4.95 times 9 plus 4.95x. I have an x on the left and an x on the right. Let's get rid of the one on the right because it's more pleasant. Minus 4.95x minus 4.95x. Cross you out. 9x minus 4.95x is 4.05x. Use a calculator. That's going to equal 44.55. X is still not alone by itself. It's being multiplied to 4.05. So let's divide both sides by 4.05. Divide both sides by 4.05. And you're going to end up getting a terrible, terrible, terrible number. 10.98765. I'm not joking. 4321, blah, 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 blah. So what we'll do is, how long would it take Paul to do it alone? We'll round this up to 11 hours. Is it exactly 11? No, but 10.98 hours is close enough to 11 hours. Okay? So work problems are not easy, not for the faint of heart, but we did it. This is called a literal equation. And with literal equation, you're going to have several variables floating around, and your job is to solve for one of them. But don't worry, the same exact rules apply. My job is to solve for A. I need to get A all by itself. So let's take a look at what surrounds A. I have 12 being multiplied to A, and I have M being multiplied to A. So if 12 is being multiplied to A, how do I get rid of 12? Divide 12. If M is being multiplied to A, how do I get rid of M? Divide M. If I'm going to do that to the left, I'm going to do the same to the right. So 12M is being divided on the left. The 12s cross out, the M's cross out, and the A drops down. Now on the right side, I have 4 over 12M. And you might be thinking, wait a minute, 4 over 12, doesn't that simplify to 1 over 3? It sure does. So if you can simplify, simplify. So that becomes 1 over 3. What about M? M just comes along for the ride. It's part of the answer. And don't be like, whoa, 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 we did something wrong. You have letters in your answer. I know. It's a literal equation. You're supposed to. That's our guy, though. Easy. Solve for A. This is called a literal equation. And with the literal equation, what you're supposed to do is you're supposed to get the variable you care about all by itself, knowing very well there's a bunch of variables in the way. So what do I have? I have M on top in the numerator, A in the denominator, and B just floating around. Well, how do I get rid of a B just floating around? Let's subtract it from both sides first. So that leaves me with Z minus B equals M over A. Okay, now I'm going to approach this differently. I'm going to put this over 1. My job is to get A all by itself. If I put this over 1 and rewrite it so that it looks a little bit prettier, like so, I now have a proportion. And with a proportion, what you do is you cross multiply, so 1 times M is 1M, or just M, and that's going to equal A times Z minus B. Now, since this is a group in a fraction, I'm going to make sure I put it in parentheses. Now, I know what you're thinking. Let's distribute. No, no, no. My job is to get A completely all by itself. I have a parentheses of stuff being multiplied to A. How do I get rid of a parentheses of stuff being multiplied to A? Divide that parentheses of stuff from both sides, like so. That crosses out. Now I'm going to write it over here on the right side because I'm running out of space. Okay, but that leaves me with M over, I don't need the parentheses anymore, Z minus B equals A. A is all alone now. Some teachers might be okay with that and say, that's fine, but I prefer to have my a on the left. So if m over z minus b equals a, then a is going to equal m over z minus b. It's the same thing, just written backwards. This is prettier, but that's okay. Okay, so that's a literal equation. This one was very, very, very tricky, but we got the job done. Literally. Oh, thanks for watching.